Okay, how do you write half ion reactions? What are half ion reactions really? Whenever you take redox reaction, all right, uh, in redox reaction, in redox reactions, uh, if oxidation reduction, oxidation reaction, and reduction reaction are written separately. They are called half ion reactions. They are called half ion reactions. All right. Fine. Now, specialty about half ion reactions is this. Now, all this time we were balancing complete reactions. In those, we did not use electrons. Okay, but in half ion reaction, the important point is they will have electrons in them. Half ion reactions consist of electrons. So we use electrons and H plus and OH minus depending on the medium to balance the reactions. Right. And the next point, when half ion reactions are added, when half ion reactions are added by balancing the electrons, the complete balanced reaction can be obtained. The complete balanced reaction can be obtained. Okay, complete balanced reaction can be obtained. Right. So these are a few things you need to know, but more if you do some examples there, that's when you will understand it better. Right now, let's start with examples straight away. Example one, I'll go with the most common and the simpler one we've been always studying. Permanganate reacting with Fe2 plus, and it produces Mn2 plus and Fe3 plus. And let's say you are asked to balance it in acidic medium. Acidic medium. Okay, right. Now you have to write 3 steps. First step is oxidation half ion reaction. Second step is reduction half ion reaction. Now you can write the reduction first, oxidation second. It's up to you. And then you have to write the finally you have to write the complete balanced reaction. That's the task. So first and foremost, you have to identify the species which are undergoing oxidation and reduction. That's important. Now, if you take manganese from +7, it goes to +2. Manganese from +7 goes to +2. So what's happening there? Manganese is getting reduced. Manganese is getting reduced. So I will explain this to you in step by step. In the other examples, you don't have to do it step by step like this. Right. So this is reduction, correct? This is reduction. So permanganate is undergoing reduction. On the other hand, if you look at iron, from +2, it goes to +3. So that path is oxidation. This path is oxidation. Now I'm doing all these things just to explain you. First, you have to identify this. You can do it in your head. You don't have to write all these arrows and everything. I'm just writing these things to explain you how it is done. Right, fine. Now, first and foremost, you have to understand something before we move on to the half ion reactions. Oxidation. The process of oxidation means during oxidation, electrons released. That is what oxidation means. Okay, or in other words, oxidation number increases. Oxidation number increases, true, but this is also equally important. You knowing that electrons will be released during oxidation, and during reduction, if a species is undergoing reduction, that species should gain electrons. So reduction means electrons gained. So that's crucial. You have to keep this in mind. Right. So let's go in this order without getting confused. I'll start with oxidation half ion reaction. Oxidation half ion reaction. Right. Let's start off oxidation half ion reaction. So how do you do that? Perhaps I might have to explain this step by step for you to understand. First of all, oxidation half ion reaction, you have to write the species Fe2 plus is becoming Fe3 plus. Fe2 plus is becoming Fe3 plus. Okay, right. Now, from +2, it has gone to +3. From +2, it has gone to +3. So what is the difference in oxidation state? 1. Just 1. And to balance that, you have to put an electron on the right side. Now, it means two things. One, it means the oxidation number has increased by 1. So 1 electron is released. If the oxidation number is increased, 1 electron is released. And now check the number of atoms. I have one ion here. And look at the total charge, +2 here. +2, 1 electron, you have to take it as -1. So +3 -1, +2. The atoms are balanced. Charge is also balanced. This is very straightforward, nothing much here, very easy. And let's move on to the reduction half ion reaction. This might be a little bit challenging, right? Reduction half ion reaction. Right, who is undergoing reduction? That is permanganate. So MnO4 minus, let's leave some space and write Mn2 plus. It is becoming Mn2 plus. Okay, right. Just like before, compare the oxidation states from +7 goes to +2. You don't always have to write this like this at the bottom. You can do it in your head with practice. Now, oxidation number has reduced from +7 to +2. So reduction is 5. That is because it has gained 5 electrons. It has gained 5 electrons. Hope you understood that. It has gained 5 electrons. And then you can do it in different ways. Easiest method would be to balance the oxygen atoms. Balance the number of oxygen. So we have 4 here, 4. To balance that, I have to put 4 water molecules. To balance 4 oxygen atoms, you put 4 water molecules. And finally, we need to put H plus, correct? We need to put H plus to balance the hydrogen atom, because the reaction is happening in what medium? Acidic medium. Don't forget that. Reaction is happening in acidic medium. I have 8 on the right side. So you put 8 H plus on the left side. That way, you can balance hydrogen as well. Okay, right. Now this is the oxidation half ion reaction. This is the reduction half ion reaction. Now this reaction can be balanced in another method as well. MnO4 minus becoming Mn2 plus. +7 oxidation state, +2 oxidation state. Right. So what has happened? 5. The reduction in oxidation state is 5. So 5 electrons must be gained. Manganese is already balanced, so 5 will be. Then you have to check the charge, total charge. What is the total charge on the left side? It is -6. -1 plus 5 minus 5. So altogether -6. And on the right side, what is the charge? Only +2. -6 here, +2 here. Okay, and we should use H plus to balance this reaction because the reaction is happening in acidic medium. So to which side should we add H plus? If I add more H plus to right side, what will happen? This plus will become even more positive. So you will never be able to balance. But if I put H plus on the left side, then you can convert this minus also to plus. And how many H plus should I be adding? 8. Because 8 plus 8 minus 6, it's +2 again. All right, and then finally 8 hydrogen atoms are there on the left side. To balance those 8 hydrogen atoms, I have to put 4 water molecules. Either way, you will get the same answer. So it's up to you. But In my personal opinion, balancing oxygen is less risky, because here you might make small calculation errors when you compare charges. So the earlier method we used by balancing oxygen, in my opinion, that is risk-free. And now to finish this off, now there is another thing. It's not just writing half ion reactions. You need to get the final completely balanced reaction also. For that, what we need to do is, in each reaction, we need to make sure that number of electrons are same. In the first reaction, we have 1 electron. In the second reaction, we have 5 electrons. So if you take this as equation 1, and if you take this as equation 2, you can do one thing. That is multiplying the first equation by 5. Why am I doing that? That way you can balance the number of electrons in either equation, right? In both the equations. Sorry. So it should be 5 Fe2 plus, sorry, not plus, 5 Fe2 plus. I'm multiplying the first equation by 5, and that will give us 5 Fe3 plus and 5 electrons. Let's take it as a third equation, right? Now in the second one and third one, we have equal number of electrons, because in the finally completely balanced reaction, final complete balanced reaction, you can't have electrons. So you need to get rid of the electrons. Right, now let's add second and third. If you add second one and third one, what will happen? Electrons will get cancelled out. On the left side I have 5, on the right side I have 5. They will get cancelled out, and the remaining ones, 5 Fe2 plus, you just write them, 5 Fe2 plus MnO4 minus plus 8H plus, and on the other side 5 Fe3 plus Mn2 plus and 4 water. This is the completely balanced reaction. But in the previous method we discussed, we did this in just one step. But in this method, you have to write 1, 2, add them. Sometimes you might have to multiply both the reaction to get the common multiple, and then you have to add it. So a lot of steps involved here. But if you can write this reaction in any way, in any method, you will get the full marks, because they will ask you to balance the reaction. If they have specified this method, then you have to do it in this method. If they might say, especially in structured questions, they will say, write the oxidation half ion reaction, write the reduction half ion reaction, then write the completely balanced reaction, ionic reaction. Then you have to follow this method. But in an MCQ or in an essay question, if all you need is this reaction, then I don't really recommend you to go to this method, because this can be time consuming. But listen, if you can do this fast, and if you still can get this at a quick time, doesn't matter. The method doesn't matter, but you have to do it correctly and quickly. Now, this is the second example we are going to consider, right? Reaction must be balanced in acidic medium. We are going to write oxidation and reduction half ion reactions, and to get the final answer. Manganese from +7 goes to +2. Oxalate +3 goes to +4. Carbon +3. Okay, now you know who is undergoing oxidation, who is undergoing reduction. All right, fine. So let me start. Oxidation half ion reaction. Oxidation half ion reaction. Right. Who is undergoing oxidation half ion reaction? Oxalate. Correct. Oxalate. It's going to get oxidized. So let's start. C2O4 2 minus. That is becoming. Always leave a space, because you might need to add other stuff. Is becoming carbon dioxide. All right, just like I mentioned before, from +3 it's going to +4. Right, first and foremost thing you have to do in these situations is balance the carbon atom, which is undergoing oxidation state. Here I have 2, here it's not balanced now, so you balance it first. Here we have 2, here put 2, it's balanced. All right, that's step 1. Right, so step 1 was balancing carbon atoms. I'll just write the steps here. Balancing carbon atoms. Right, and the next step, +3 to +4, change in oxidation number is 1, but there are 2 carbon atoms. Therefore, how many electrons are going to be released? 2 electrons. Guys, there are 2 carbon atoms. Each carbon atom's oxidation number has changed from +3 to +4. So each carbon atom will be releasing 1 electron. Therefore, you have to put 2 electrons. Okay, so second one, adding electrons. Adding electrons. So electrons we added here. How? It was actually 2 into 1. It was not 1 into 2. Difference is 1 into 2 carbon atoms. And then number 3, balancing charges. Balancing charge. If you look closely, everything is balanced, people. Everything is balanced. 2 carbon, 4 oxygen. 2 carbon, 4 oxygen. Minus 2 is the charge. Minus 2 is the charge. This is it. It's already balanced, the reaction. Okay, it's already balanced. And then next we have to go for the reduction half ion reaction. Reduction half ion reaction. Reduction half ion reaction. The thing is, it's the exact same reaction we discussed in the previous example, because permanganate is turning to Mn2 plus. So I'm not going to spend a lot of time. Let's quickly finish it off. Permanganate is becoming Mn2 plus. Right. Permanganate plus 7 from plus 7. Permanganate manganese is plus 7. Here it is plus 2. So what has happened? There's a difference in 5 electrons. So it will gain 5 electrons. And then I have to balance the oxygen atoms. I have 4 here. So I will add 4 H2O here. And then to balance hydrogen atoms, we'll put 8H plus. That's it. Now, what's the problem? The number of electrons, again, not the same. Number of electrons are not the same in both the reactions. So I'll take the first reaction as the first one, reaction 1, and this one as reaction 2. Here we have 2 electrons, here we have 5 electrons. Here we have 2, here we have 5. So by just multiplying one reaction, you can't balance the number of electrons. So what should be done? First reaction must be balanced by 5. So we will be getting 5 C2O4 2 minus, and on the other side 10 CO2 plus 10 electrons. And the second one should be multiplied by 2. Then only electrons can be balanced. And you can't deal with fractions. Everything must be integers. So here we have 16H plus, 2 MnO4 minus. You have to be very careful. Each component must be multiplied by 2. And 10 electrons, right? And on the right side, 2 Mn2 plus 8 H2O. Right, 3 and 4. And finally, you will be adding 3 and 4. So when you add 3 and 4, what will you be getting? 5 C2O4 2 minus plus 2 MnO4 minus plus 16 H plus. And the products, electron and electron will get cancelled off. That's all. And on the other side, we have 2 Mn2 plus 10 carbon dioxide and 8 water molecules. There are instances where water molecules might be there in both the reactions. Sometimes on the right side, sometimes on the left side. So there you have to be a little careful. In the first 2 examples we have considered so far, only electrons were there in both the reactions as a common component. And since they were on the either side, when you add, they will get cancelled. And this will be the ultimate reaction. Finally balanced reaction. Right, third example, dichromate reacting with sulfur dioxide forming Cr3 plus and sulfate ions. First of all, you have to consider the oxidation states and identify the species which is undergoing oxidation and the species which is undergoing reduction. So chromium from +6 has gone to +3. It is undergoing reduction, whereas sulfur from +4 has gone to +6. It's undergoing oxidation. And medium is acidic, therefore we have to use H plus ions to balance it. Let's start. Oxidation half ion reaction. What is the oxidation half ion reaction now? Sulfur dioxide, it's turning to sulfate ions. Okay. plus 4 is the oxidation state, and plus 6 is the oxidation state here. Therefore, you can notice there is a difference of 2 in oxidation states. That means sulfur atom has released 2 electrons because there's only one sulfur atom here, one sulfur atom, therefore 2 will be released. Okay, already balanced sulfur 1 and 1, so 2 electrons. And then you can do it in 2 ways. One, you can balance the oxygen atoms. If not, you can balance the charge. So I will balance the oxygen atoms. On the left side, I have only 2 oxygen atoms. But on the right side, I have 4 oxygen atoms. Therefore, I will put 2 water molecules on the left side, like this, to balance the oxygen atoms. Okay, 2 water molecules on the left side. The oxygen atoms are balanced. And now let's balance the hydrogen atoms. Let's balance the hydrogen atoms. I have 4 on the left side. I have none on the right side, acidic medium. So I have to put 4H plus to balance hydrogen atoms. Okay, not very hard, not rocket science, quite manageable. And next is a reduction half ion reaction. So let's write it, reduction half ion reaction. Right, who is undergoing reduction now? Dichromate is undergoing reduction. So last time I made a mistake by not leaving enough space. This time we'll write with sufficient space. Dichromate, it's becoming chromate, Cr3 plus. And chromium here is plus 6, the oxidation number, and here chromium is plus 3, the oxidation number. First and foremost, you need to balance the chromium atoms. Now here we have 2 chromium atoms. Here you add a 2 to balance it off, first of all. Earlier, we didn't have that problem, 1 sulfur, but here you have to be careful. And chromium, from plus 6 to plus 3, each chromium atom will do that. So each chromium atom is gaining 3 electrons because this is a reduction reaction. Oxidation number is reducing. So if one chromium atom is gaining 3 electrons, 2 chromium atoms must have gained 6 electrons. 2 chromium atoms must have gained 6 electrons. Right. So now electrons are balanced. And then you have to balance oxygen. I have 7 on the left side. I have none on the right side. So I will put 7 water molecules. And then to balance hydrogen atoms, I have to put 14 H plus on the left hand side. Right. This is different than the previous 2 examples because you can see, if you look closely, you can see on either side we have electrons, H plus and water molecules too. Everything is there. Okay. Right, reaction 1, reaction 2. Electrons not balanced, 6 here, 2 here. But the good news is if you multiply only 1, it's enough. So first reaction can be multiplied by 3 to get the number of electrons to 6. So if you multiply the left hand side by 3, it will be 6H2O plus 3SO2. And on the right hand side, 3SO4 2 minus plus 6 electrons plus 12H plus. 12H plus. And that is the third equation. Now, when you add them, you have to be very, very careful. When you add them, you have to be a little careful. You are going to add 2 and 3. You are going to add 2 and 3 because in 2 and 3 we have electrons, equal number of electrons. Let's start from one corner. Okay, let's start from H plus. I have 14 H plus here. I have 12 H plus on the right side. So 14 plus 12, right side dominating 2 H plus will remain. Dichromate, I have only one dichromate on the left side. So it will be Cr2O7 2 minus. And what else do we have on the right side? Water. I have 6 water molecules on the left side, 7 water molecules on the right side. So we have more water molecules on the right side. Therefore, water molecule is going to remain on the right side. SO2 only on the left side. So 3SO2. And then let's go to the right side. We can write chromate ion plus sulfate ions. Electrons will get cancelled off. H plus we have already balanced. 14, 12. On the left side, we have 2 extra. We put that here. And water molecules. On the right side, we have 7. On the left side, we have 6. So you have to put 1 on the right side. And that would be the final answer. Right. That is how you balance it. If you get water molecules and H plus on either side. Fourth reaction, we have permanganate reacting with hydrogen peroxide, manganese 4 oxide and oxygen are released, and you have to, no, the reaction is happening in basic medium. You have to balance it using OH minus ions this time. Right, first step is same, oxidation number +7 +4, so it is undergoing reduction. H2O2 from -1 it goes to 0, so it is undergoing oxidation. Right, only difference is you are going to balance it using OH minus ions. Let's start. Oxidation half ion reaction. Right, oxidation half ion reaction, we should start with H2O2 and it should become O2. Right, H2O2 becoming O2. Let's start with the oxidation states. From -1 it has gone to 0. So there are 2 oxygen atoms. Each oxygen atom has gone from -1 to 0. So difference is 1, but there are 2 oxygen atoms. Therefore, I need to put 2 electrons on the right side to balance it. And next, since this is basic medium reactions are easier if you balance them using charge. Now look at the right hand side. What is the total charge we have on the right hand side? -2, because there are 2 electrons on the right hand side. On the left hand side, what is the charge we have? 0. No charge is available on the right hand side. Therefore, to balance the right hand side, I have to put 2 OH minus here. 2 OH minus here, because here -2, here no charge, so I put 2 OH minus. And finally, balance hydrogen atoms using water. I have 4 hydrogen atoms on the left side, so I need to put 2 water molecules on the right side. Reaction is balanced. Yeah, then the next step is going to be reduction half ion reaction. Reduction half ion reaction. So talking about the reduction half ion reaction, permanganate, it is getting reduced to MnO2. Permanganate is at +7 oxidation state. MnO2 is at +4 oxidation state. So you can notice manganese 1, only one manganese atom has gained 3 electrons. That's why the oxidation number has reduced by 3. All right. And again, we have to balance this using OH minus. So you have to consider charge. What is the total charge we have on the left side now? -2, -3, -5. Electron is counted as -1. On the right side, what is the charge? 0. Because this is neutral. Then what should I do? Here -5, here nothing. We have to put 5 OH minus on the right side. 5 OH minus on the right side. Okay, good. Now, if you want to balance, hydrogen, there is a problem, na people. There is a problem. What is the problem? 5 hydrogen, but I can't put water molecule, because in water molecule hydrogen is what? In even numbers. Therefore, this entire thing must be multiplied by 2. Because if I want to put water molecules, I will have to put 2.5 water molecules. That must be a little confusing. No? So let's multiply everything by 2. So when you multiply everything by 2, what will happen? You multiply everything by 2. Well, this will become 5 OH minus. Sorry, 10 OH minus. This will become 2. This will become 2. And electrons, you should put 6 electrons. All right, fine. And to balance hydrogen, I have to put 5 water on the left side, because there are 10 hydrogen atoms. So I put 5. And if you look at oxygen atoms, they are balanced, aren't they? There was an error in the previous balancing. I had put 2 minus here by mistake. I'm extremely sorry. So let's start from here very quickly. This is +7. And here it goes to +4, and we know now, you can see manganese has gained 3 electrons, so we put +3 electrons. Okay, it has gained 3 electrons, right? And then next step, what should we do? We have to balance the charges. So here we have -4. -4 is the charge. In the early one, I made a mistake. It looked -5. minus 4, and here it is 0. 0. Right. Then to balance the charge, here we have minus 4, here nothing. I have to put 4 OH minus on the right hand side. That way, charge is balanced. And then hydrogen atoms must be balanced. I have 4 on the right side. I have none on the left side. So let's put 2 water molecules. And if you want to be absolutely sure, you can check oxygen atoms. 2 plus 4, 6. 2 plus 4, 6. Okay, right. Then we have 1. Sorry, this is reaction 1. This is reaction 2. Right, so what should we do now? 2 and 3. So this reaction must be multiplied by 3. This reaction must be multiplied by 2. We are done with half ion reactions, but using that, if you are supposed to find the final answer, then the first reaction must be multiplied by 3. What will I get? 3H2O2 plus 6OH minus, and then on the other side 3O2 plus 6 electrons plus 6 water molecules. Third equation. And then the second one must be multiplied by 2. What will I get on the right side? 4 water molecules, 2 permanganate, and 6 electrons. And on the right side, 2MnO2 plus 8 OH minus, the fourth one. Right. And then we need to finish it off by adding everything. Now, when you add, you have to be a little careful. H2O2, we have only on the left side. So let's write 3H2O2. Permanganate, we only have that on the right side. So 2MnO4 minus. What else? No, 6 OH minus, 8 OH minus. We have more on the right side. Water 6 here, 4 here. We have more on the right side. Electrons going to get cancelled off. So this is it. And on the right side now, what do we have? There will be 3 oxygen molecules, 2 MnO2. And in addition to that, look at water molecules now. I have 6 on the right side. I have 4 on the left side. So 2 water molecules on the right side. And OH minus, I have 6 on the left side. I have a 2 on the right side. Therefore, 2 OH minus. This is the final answer. I think we balanced this today under balancing of under balancing in basic medium. We did the exact same reaction. So this is the answer.